Hi Margie, I promised you a video to explain what you're doing in linear algebra. And so let's just try to break it down to make it really, really simple. I'm going to base it on something that you learned way back in high school. And that was that sometimes when we have two straight lines on a graph, they cross or intersect. And we want to know the point of intersection, so we short form that POI. And if we can find that point of intersection, then that's important for a lot of different math problems, and it doesn't really matter for what right now, but I just want to sort of start with something that you've already learned and can kind of relate this back to. All right, so we had a method of being able to find the point of intersection if we knew the two equations of the lines of these two lines. But that only works if we have just two lines. If we move that up to where three lines intersect, or if we even move into three dimensions, which is real life, right? Like everything in our world is three dimensions, then the method that you learned in high school doesn't work anymore. So we're not even going to go back and look at it. It was called elimination or substitution if you just are trying to remember it. But it doesn't work except for when we have two straight lines in two dimensions. So that's where linear algebra and matrices come in. And you mentioned a couple of terms. The first term that you mentioned was reduced row echelon form. And so a lot of times you'll see it written like that, or just REF. And the other term that you're going to hear a lot is Gaussian-Jordan elimination. So Gaussian-Jordan elimination. And that is sort of the same thing. They're related anyways. Gauss is a mathematician from a long time ago who was a very arrogant mathematician and knew everything by the age of 12, and nobody could teach him anything more, so his dad had to put him in a special school to keep learning math. Sorry, I was just interrupted by somebody coming in the room there. Okay, so Gaussian-Jordan elimination is the other term that you're going to hear a lot. And I know they sound like something complicated, but let's make it easy, okay? So what we're going to do is, like I said before, it's kind of like playing a game. We're just going to take the numbers only from this equation set that I have up here. There's three equations, and I've numbered them 1, 2, 3. And I'm just going to take those and I'm going to put them in matrix form. So I'm going to have a 2 and a 3. And instead of the equals, I'm going to put a vertical line, and then I'm going to put the 12 on the other side. Then I'm going to have a 1 and a 1 for the coefficients of x and y, and a 5 here, and then a 2 and a -1 and a 1 here. So the object of this game is that we want to break this down, and what we want is to have this form left over. This is reduced row echelon form. And so you notice that we have the diagonals here with ones. That's when you know that you're in reduced row echelon form. You can stop before you actually get there, and we'll get to that later on. But for now, that's what we're going for. That's the object of the game. And the way that we get there is we just do operations on the rows, not the columns, just the rows, to try to sort of knock out the numbers in the different places so that we only have zeros and ones left over. So, for instance, if I take row 1 and I just subtract the numbers from row 2, then I would have 2 minus 1 is 1, 3 minus 1 is 2, and 12 minus 5 is 7. And then all my other rows are just going to stay the same. So this just becomes a really painstaking process, unfortunately. And of course now we have computers to do this for us. But I've achieved what I wanted, which was to have a 1 here and a 1 here. Okay, now because I've got 3 rows but only 2 columns, one of these rows is going to end up just coming out to all zeros. So don't worry too much about that. We're just going to look at the 2 rows for whether or not we win this game, okay? So here's my next move in the game. My next move is to take row 2 and just subtract row 1 from it. And so I'm going to rewrite row 1. It's not going to change. But row 2, because it's the first one in my instructions that I wrote, it's going to change this time. So if I take 1 minus 1, I'm going to get a 0 there. And then if I take 1 minus 2, I'm going to get minus 1. And if I do 5 minus 7, I'm going to get minus 2. And I'm going to leave that third row alone for now. So if I just now take row 2 and multiply it by negative 1, then I've achieved half of what I need in this game. I've already got one row that's in that form 0, 1, something. And so what that actually tells me is that because y is the second variable, like we know how we do x, y, z, right? So in order, y is the second, then this represents 1y, and this represents its value. And so I already know now that y has to equal 2. And if I want to do one last step on this, I can now take row 1, and I can minus 2 times row 2, and I'm going to get 1, 0, 3. I already had 0, 1, 2. And then this bottom row doesn't really matter because, like I said, we only need 2 of our rows to give us the answer for x in this column and y in this column. So now I know x equals 3 and y equals 2 is the point of intersection of these 3 lines. And that's all that you're doing with matrices when you're just trying to solve a matrix using reduced row echelon, like putting it in reduced row echelon form. And the process is called Gaussian-Jordan elimination. So that's really all it is. And like I said, it's almost like a game because you see the next move and you get excited. You're like, oh, I can make a 0 in that spot if I just subtract this one from that one. And then the third row here, it doesn't matter in this case because we only have 2 variables and we've been able to solve for x and for y in the top 2 rows. If we had 3 variables, then our matrix would look different. We would have 3 numbers like A, B, C, and then our answer over here. And we would have 3 rows of numbers, GHI, like that, and we would actually have to work with all 3 rows and try to get it down into 1, 0, 0, 0, 1, 0, and 0, 0, 1, like that. So it really, I think you're going to really enjoy this because you just have a brain for this. I can tell you do. And if you just look at it as a game and you're looking for your next chess move kind of thing, that you're going to be able to get a 0 in the right spot. You can even switch rows if you need to. You can do any sort of operation that's allowed in math to try to make these into this form when you're done. And of course, whatever's on the right-hand side of the line is the first one is your x value, the next one is your y value, and the third one would be your z value. And yeah, you can keep going. We would have w as the next variable and so on, so they can get bigger, but they also get a lot more complicated with a lot more steps.